Data analysis for the free fall lab. Okay, so you should have already gotten your distance data from measuring the distance from the first dot to all the others. This is my simulated data that we're going to use to show you how to get the velocity calculations and then eventually to get the acceleration due to gravity. So normally we would take slopes, but since the distance time graph is going to be a curve, it's hard to take the slope of a single curve, but we're going to use line segments to figure that out along with the slope formula. Now the slope formula is y2 minus y1 over x2 minus x1. And we're going to use that to figure out the velocity for each one. So what we're going to do, if I want to find the velocity at 1/60th of a second, I want to come over to my data, cover up 1/60th of a second, and use the point after and the point before as my 2 points in the slope formula. So when I do that, so for 1/60th, I'm going to take the point after, 0.5, minus the point before, 0, over 2/60ths minus 0 over 60. And when I do that, I get 0.5 over 2/60ths. Well, 2/60ths reduces to 1 over 30. When you got a fraction on the bottom, you flip it up. So that essentially becomes 0.5 times 30, which is 15. So my velocity for 1/60th of a second is 15 centimeters per second. And we're going to do that for another one. Let's do it for 2/60ths. So for 2/60ths, again, I want to cover up that one, take the point after minus the point before. So I get 1.2 minus 0.1 over 3/60ths minus 1 over 60. And I get 1.1 over 2/60ths. Again, that reduces to 1 over 30. That's going to be a theme. And we get 1.1 times 30, which equals 33. So my velocity for 2/60ths is 33 centimeters per second. So here's the shortcut. The bottom is always going to end up 2/60ths, which always reduces to 1 over 30. So we always end up on that last step multiplying by 30. So for 3/60ths, I want to show you the shortcut. Again, we cover up 3/60ths, because that's the one we're looking at. We take the point after minus the point before. So 2.2 minus 0.5. And that gives us 1.7. And we just realized that we're going to multiply by 30. And so when we do that, 1.7 times 30, we get 51. So we get 51 centimeters per second. So all you have to really do is take the point after minus the point before and then multiply by 30. Point after minus point before, multiply by 30. Point after minus point before, multiply by 30. And then what you're going to do is you're going to graph the velocity time graph. And when you do, you can keep the bottom scale pretty much the same, whatever you had for the distance time graph. That would work. Remember, they're all over 60th of a second. But you're going to have to figure out a new scale for the side. Remember, to find out the new scale, you just take the largest number that you have to graph and divide by the number of blocks along that side, and then round up. So it's a nice number to count by to figure out your scale. You should get a nice straight line. Well, not necessarily perfectly straight. You might have some hiccups and stuff. But remember, we don't play connect the dots. We should just get one single line of best fit. And you're going to take 2 points off that line to find the acceleration due to gravity. Again, using slope. But this time, we're not going to take 2 points that are really close together. You're going to take 2 points off your graph. Make sure it's on your line, off your graph, and preferably as far apart from each other as possible. And just remember that all these times at the bottom are all over 1/60th of a second. Okay, and you should get a number, since we're keeping it in centimeters, somewhere around 800, 900, maybe low thousands. And then do the percent error, where the percent error is your experimental value minus the standard, which where this one will be 980, divided by the standard, again 980, then times that by 100 to change it to a percent. Okay, there you go. That's how to do the free fall lab analysis. Good luck, and see you later.